prazer, a gente tem agradecemos a presença do professor Lynch, que é professor da Universidade de Adelaide, professor visitante também da Universidade de Virchow, no Reino Unido. Ele vai estar falando hoje com a gente sobre as intervenções na saúde infantil. I was just translating the type of presentation, so it's up to you. So thanks a lot for being here with us.
Thank you very much, and welcome everybody. Thanks for being here so late on Friday afternoon. I'm sorry I couldn't get here earlier in the day. So I hate holding these things, and I'm going to move my hands around, so we'll see how I go. But thank you for turning up and the invitation to be here. So I'm going to tell you a little bit about some of the work that we do. And it's generally in this area of child health and development interventions. But seeing it's such a nice small group, feel free to stop me anytime. I don't care if we get through all the slides or not. So if people have got questions or comments, please stop as we go along. So I guess it won't be any news to anybody in this room that I have interests in intergenerational social inequality and health inequality. The basic map, we begin with adult social and health disadvantage. That generates child health disadvantage at birth, developmental disadvantage, early learning disadvantage, educational disadvantage, and eventually labour market income disadvantage. And then that generates the next generation of adult health and social disadvantage. So we work in this space, and I'll say a little about why we do. But one of the things that we'd like to be able to achieve, is to see what can be done in this space that helps break these links. So that's why we work with children and families, especially in this age range from conception through till about age 8. So the randomised controlled trial evidence around child health and disadvantage is quite limited. And there's lots and lots of things that people do to help disadvantaged families and children. But from an epidemiological perspective, only about 15% of all of those interventions have what we would think of as a sound base in randomised controlled trials. Also, there's little insight into the mechanisms, how these things work. And we get that a lot with randomised controlled trials because we give people interventions and some black box operates. And we don't know very much about the mechanisms of successful interventions. We know very little about scale-up effects. Randomised controlled trials will give us an average treatment effect, but we have very little idea what would happen if we actually offered that program to the entire population who might be eligible, and what that would do at the population level to the outcomes. And the other thing that occurs in the child health space is that we have interventions in discrete time periods. So what I mean by that is people will come in and intervene antenatally, then another group of people will come in and intervene postnatally, and another group will come in preschools. And nobody ever connects those interventions up. So we really don't know anything very much about what sustained interventions for disadvantaged children would look like. And by sustained, I mean from conception all the way through into the early years of school, that there was a sustained program of support for those kids. I don't think anybody in the world actually knows what those effects might be. And then there are other potential interventions where we have no evidence at all. And then finally, we'll never have all the randomised controlled trials that we need. We'll never be able to afford them. They won't be timely enough. We won't be able to wait long enough to follow them up. And some of them would be unethical. So to me, that means we've got to use observational data in different ways. And that's partly what I'm going to try and talk about today, with some of the newer methods that come in. So I guess everybody in here is familiar with the 3 tasks of epidemiology, but I'll review those for you. The first one is to describe health status. We describe outcomes. We give descriptions of whys, whether that's mortality, infectious disease rates, prevalence of smoking, we do a lot of descriptive work on describing whys. The next task is to find what causes why. In this case, I've drawn this DAG book. We've got X's and Y's. I guess everybody's okay with that, right, that notion? We're going to try and find X's, and we want these X's to be causal. And I'm of the opinion that we should not shy away from causation. That's our job. We're not interested in associations. We are interested in causes. Why? Because we want to change things. And to do that, we intervene on causes, and that's the third goal of epidemiology. I guess I should say I can see people taking pictures and writing notes, and if you want these slides.
Something because it's in the process of medicine as campus departments, technology, social science, and so maybe some of the students who are not from the department. But I mean, as here, as you say, even a non-epidemiologist can cause.
You can?
Yes.
Good. Okay. I'm happy for you to have copies of these slides so you don't have to take pictures and write notes. And
It's going to be taped anyways.
yeah, you can just listen, and I'll somehow give you a copy of the slides, and then but only for the people here. People that are not here don't get the slides, okay? So that will save a lot of film on your camera. So I was talking about we want X's and Y's. We want to have them be causal. But then the third goal is to intervene. And that means we want to change X's, but we're also interested in M's, in mediators, in the mechanisms. So the example I would give is that we have poverty directly causes child mortality, but part of the effect of poverty is it increases exposure to lower water quality, and that also causes mortality. And if you look at some of the great public health interventions, they're not on X's, they're on M's. So the sanitary revolution was not changing the amount of poverty in society. There were still plenty of poor people, but what we did was give everybody clean water and sanitation. So you break this link. And that's been a common practice in public health intervention, and why we think universal services for everybody matter. So my point here is that there are X's we want to change, and there are M's. And then if we're using observational data, this thing called time-varying confounding that I'm putting in as an L is a really tricky thing to deal with. And it's even a tricky thing when this exposure is a randomized control trial. In other words, there's no confounding, there's no other causes. But something that happens post-randomization as part of the mechanism, because of time-varying things that change, is a real problem. So for those of you who understand randomized control trials, the classic example is poor compliance. People are not complying with their exposure. Something changes in the way they get exposed to treatment. And that is a time-varying confounder that's after they've been randomized. So that turns out to be a very tricky thing to deal with. Okay, so as I said, we're interested in this space in here, and I made this term up, you won't find it in a book anywhere. It's called interventional epidemiology. It sounds very important, doesn't it? I just made it up, it's okay. But what we're trying to do is to run randomized control trials. We're trying to do and use natural experiments, and we try to use observational data, and we try to make them all connect up through simulations in various ways. And that's really what I want to talk to you about, is our program of work that's trying to address these challenges of childhood health and development for kids from sort of under 8. So let me step back a little bit, and I'll take you through why are we interested in early life. Now, some of you may be well versed in child health and development, others not. So I'll give you the quick 5-minute version of why we think this matters. So if you look over here, this part of the slide, it relates to brain weight. So in the top panel, you'll see that 90% of the weight of the brain is there by age 5. That's why when you see little babies, they've got big heads. And there's a lot going on in there. But you achieve 90% of adult brain weight by age 5. In the second panel, as a proportion of body weight at birth, for a newborn, the baby's brain is about 13% of their body weight, reducing down to 2. So there's a lot going on in these early years in terms of brain development. And you've probably seen these kinds of charts. So these are the months in utero and then postnatally. And the point of this is there are various developing systems with seeing and hearing first, with later on you get higher cognitive functions emerging. But the thing to notice is that all of these decline by age 5, 6 or 7. In other words, the rate of activity of new neurons and synaptic pruning is going down. That doesn't mean that it's all over by the time you're 6. Obviously these things go on, but it is this rapid growth in the early years that people think is why it's particularly important. And you'll see up here I've highlighted this thing called experience-dependent synapse formation. And that really is saying that the neuroscience of this consistently shows that experience shapes the biology. So it is the exposure to environments that is an inherent part of this process of brain development. So I think we know a fair bit about what happens when children are deprived of that experience. We know much less about what happens when they're in situations where their environments are enriched. So what I mean by that is some of you may have seen this study in Science. This is the Romanian orphan study. And in a randomized control trial, they compared abandoned children who were in institutions. They had been abandoned by their parents. They compared children who were abandoned in the institution to children placed in institutions but then moved into foster care. So they were exposed to this environment, institutions, and then they were randomly assigned to be fostered out. Now, we could never do a randomized control trial like that in Australia. Ethics would not have it, but they did this in Romania with these orphans. And then they followed these kids up to about 6 years of age. So what you see here, these are their IQ scores at 42 months and 54 months. So these are the children who remained in the institutions and their IQs. These are the children that were fostered out, and these are the kids who were sort of the controls, the ones from the population. They're quite large differences in IQ. What's even more striking is this is the IQs by the age at which fostering occurred. So these are children who were taken out under 18 months, up to 2 years, and then up to 30 months. So the bottom line here is that if they were fostered out under age 2, there was about a 10-point saving in their IQs compared to the kids who were fostered later. So what does that mean? That is taken to mean that this period under 2 is even more important in terms of the environment that is shaping the brain. So we talk about environment, that immediately makes people think about gene-environment interaction. And that's an important part of this neuroscience story. So if experience shapes biology, this is the example, it's one of the examples of how people are trying to study environments, the experience, if you like, shaping the biology. And this is a study, obviously it's in Science, it must be good. This is sort of the poster child for gene-environment interaction studies. And the trouble is that if you do a meta-analysis of all of these studies, and they do this about 6 or 7 years later, none of them can be reproduced. So part of the reason for that is you see that it's been done in a cohort in New Zealand. So the ends that are available for this is 847 kids. So I don't know how many of you follow genome-wide association studies, but the kind of numbers that are required to get reliable associations between genes and outcomes, you need tens of thousands to do that, to have the ends to be large enough. That's why, you see these papers in Science and Nature, and there's 547 authors. That's because everybody's pooling their data to get the ends up high enough to have the right power. So if that's the case for genome-wide association studies, then if you do an interaction with another variable, your power just goes exponentially down. So my point is, we have these studies in gene-environment interaction, but you're never going to make it at 847 kids. We'll need 80,000 kids to do this in with any sense of power. But that doesn't mean this is not important work. It just means it's very, very difficult to do. And so I pulled this out of PLOS PLOS, what is it, PLOS genetics. These are people studying fruit flies. And so they're saying that these, in the Drosophila, the findings illustrate that gene by gene and gene by environment interactions are not just modifiers. This is core to the process. So when we look at gene environment interactions in humans, let's remember that these folks can't figure it out in fruit flies, let alone in humans. So my point is that it's a very complicated piece of basic biology that people invoke in various ways. Now, the next thing, I'm sure everybody here's heard this term, epigenetics. People talk about epigenetic effects a lot. Oh. So how many of you have heard of epigenetics? Everybody? Yeah, everybody talks about epigenetics. And I like this slide because it gives the idea that, this is all well understood and really quite simple. So at one level, epigenetics is incredibly banal. Of course, genes express. That's what they're meant to do. That's why you have an ear growing here and not a foot. Because as cells divide and replicate, they replicate in specific tissues. That's entirely banal. Yes, that's absolutely true. So, genes express, in other words, they're mitotically stable. They're stable under cell division. But the real question is, are methylation marks meiotically stable? Are they stable across generations? And many people in this field blithely say that, there's evidence that what happens to a grandmother in terms of her epigenetic methylation is then passed on to the mother and on to the child. Now, actually, there's very, very little evidence for that. There is some evidence in fruit, but this field is changing very quickly. So people use epigenetics for all the things that we don't really understand. Certainly, epigenetic processes go on, but the idea that we understand a huge amount about what's going on in terms of child health and development is just not the case. So we need to be careful how we use some of this. This is a great article by, Carolyn Relton's the final author, and she actually knows lots about epigenetics. So if you want to know about epigenetics, talk to people who actually do it, and they will tell you how complicated it is. And it changes so quickly. So I picked this out of a commentary. This is from last month. And the point of this is to say, we talk about epigenetics as if it's all well understood. This struck me that epigenetic modifications and gene activity appear not to support a strictly causal relationship between methylation and gene silencing. Sometimes methylation means, low methylation means genes are silenced. People are finding out actually it can also mean that they're highly active, overactive. So my point about this part of the neuroscience argument is that it is often oversimplified to the point that it doesn't help us very much. There is a lot of basic science to be done. And so if we're going to go across generations, there is a huge amount of basic science work that needs to be done to understand it. So watch this space, because if I come back in a year's time, this will be a different story. That does not mean it's not important. The gene by environment interaction, the epigenetic work is hugely important to understanding it, but we have barely scratched the surface. Okay, so regardless of how the neuroscience works, regardless of how the underlying biology works, what we do know is that by age 5, children who are born to a mother with a university education are around 18 months ahead on their vocabulary and over a year ahead on their problem-solving ability. So in just 5 years, they've fallen 18 months behind in their vocabulary. And that makes perfect sense. You know that. Whenever you talk to somebody, you can tell who's had the benefit of education and who has not. You can tell by the words they use. It's one of the clearest marks of social origins. And this is data for Aboriginal children in Australia. The point of this slide is, this is the educational achievement gap when the children enter primary school in grade 1 at 40%. And here's the gap when they finish primary school after 7 years. It's exactly the same as when they came in. Schools don't change these developmental gaps. In fact, some of them actually reinforce them or even widen them. So there's two things. Schools are not equipped to fix it, and the point is the gap is there before the kids ever get to school. So the argument is we need to be working before they get to school. Otherwise, these kids can't take advantage of the environments they're in. And then, of course, the economists are flooding in. I understand you had a talk this morning on economics, and the economists are flying into this field because they're interested in the sort of capability production functions that we can get from children. And that's illustrated nicely by this. So these are CT scans of kids' brains. Here's a normal CT scan of a 3-year-old, and this is extreme neglect. Politicians love this stuff because they can look at that and say, wow, it's anatomical, it's physiological, the marks are really there. And then they stack up the gold bars and they say, here's what it costs to do early intervention, keep kids' brains like this, and here's what it costs if you don't. And that's in terms of protective services, criminal activity, you know. And then some of you, how many of you have heard of this fellow, Jim Hickman? No? He's a Nobel Prize winner, so he's got to be really smart. He's jumped into this field and has been very influential. On his website just last week, he was talking about the audience that he'd had with President Obama. So he gets to talk to pretty powerful people. And he says that investing in early childhood is a social policy best buy because of these sorts of graphs. So this is the rate of return to investment in human capital. You'll see that it goes down very quickly. Here's preschool, school, and post-school. So the rate of return goes down very quickly. And this line is if you start investing, but not antenatally. So the story here is begin antenatally and begin early. Because he says that if you don't get those early skills, you don't catch up. Certainly there has to be investment later on, but the early stuff matters. And if you want to have a read of what the economists think of this field, this is a really good article from the Annual Reviews of Economics, just published last year. But in there, they talk about successful interventions alter parental behaviour, understanding why it happens, how parenting can be incentivized, and through which channels parenting influences child development are crucial tasks for the next generation of studies. And economists are very keen on this idea of incentivizing behaviour. So you have programs like Bolsa Familia, which was explained to me in Pelotas. They're doing some work with Bolsa Familia. And the cost of Bolsa Familia is, anybody know? No? It's not that big. Yeah, well, the figure that was being talked about with over $2 billion in total cost of Brazilian people. So this is a major investment. And so this idea, and conditional cash transfers are all about incentivizing behaviour. So you give people money to say, you You've got to have your child immunised, they've got to be in school, they've got to be there at least 85% of the time. So these sorts of ideas of how to improve child health and development are not going to go away. And you get major social investments and then there's opportunities in Mexico and in other places. So these cash transfers to change social behaviour, parenting behaviour, are more and more common. Now, successful interventions alter parental behaviour. I want to talk a little bit about that work. So as I said, there are lots of interventions. There's only about 15% of them have been tried in randomised controlled trials. And these are the big three. They are the nurse-family partnership or the family-nurse partnership, depending on which country you're in, the peri-preschool and the abecedarian. I'm just going to go through each one of those and give you some idea of what these trials did. Any of you heard of this guy, David Olds? He's a major player in this field. He started out in the late 60s, really, starting to do randomised control trials. And his studies have been the ones that have been rated the highest in terms of the evidence. And he runs these nurse home visiting programs. So the idea is that nurses support parenting during pregnancy and then postnatally as well, up to about age 2. And he's run these are the main series of trials. So you can see this is up in New York State in the 1970s, Memphis in Tennessee, Denver, Colorado, through to about 1995. You can see the size of the trials. They're reasonably large, 200 plus for these two. And this is the eligibility criteria. So you had to be unmarried, you had to be at first birth, and you had to be a teenager. Now that's partly because of the social situation in the US, where they're very concerned about teenage birth. Other societies are less concerned about teenage birth, but in the US they seem to think this is a massive problem, partly because their rates are quite high. For a country like Australia, our teen birth rate is under 4%. So these eligibility criteria are probably less relevant for some contexts than others. What I'm trying to show here is that if this is the best evidence we've got, when we look at this stuff from Australia, how should we judge this evidence? Is this the kind of thing we ought to be doing? I'm making the case that because it's US, because it's done where it's being done, and because of who's in the trials, I think this evidence is not very relevant for 21st century Australia. The UK may be the same, New Zealand. I'm not sure about the situation in Brazil. But these are the sorts of interventions. So the first trial was you had a screening, and then the nurse visited you during pregnancy, versus the screening, the nurse during pregnancy, but then a nurse visited up to age 2. The second trial you notice this was in whites, this one was a low-income urban black population. And then the third one, they tested it against paraprofessionals. And the bottom line is the nurses do the best job, the paraprofessionals don't get as good a result, and that's partly because of the child and family health nurses are very highly valued with a young baby. Parents would choose their advice over a general practitioner, over a paediatrician, over an obstetrician. They're highly valued professionals. And so leveraging off that high value seems to be very important, and why they get better results than lay people. So these are this is the latest results from the Denver trial, ages 6 and 9. So the kids show improved behavioural functioning, and those born to low-resource mothers benefited language and attention, but there's no improvement in intellectual functioning and academic achievement. Now that's fairly disappointing when you look at these kids at 6 and 9. It seems that the longer you wait, the lower the effects. There is a large randomised control trial in the UK that's just about to report. They've got over 2,400 people in that trial, and they will report results of this program conducted in the UK over the last 2 or 3 years. Okay, so that's the antenatal and postnatal trial. Let's have a look at these preschool trials. The most famous one is the preschool. And there's a couple of things to notice about this. First of all, it's done in 1962, and it's been done in Ypsilanti, Michigan. And because I was at the University of Michigan for 9 years, I know where Ypsilanti is, and it's nothing like Australia. Also notice the number here, they're very small. 58 intervention, 65 control. It's a very small trial. And to be in it, you had to be low-income African American with an IQ putting you in the bottom 15 to 20% for the kids, for the mums. So this is a very specific population group we're targeting. And this is what the intervention is. 2.5 hours, 5 days a week, by 30 weeks in a year, plus 1.5 hour home visit by the teacher, Piaget based. These are the child-teacher ratios, 5.7 kids per teacher. All teachers trained in child development with a master's degree. The cost of the program, around $18,000 US. This is a very intensive, very expensive program. So we have to think about which system could ever afford this going across the population. Okay, the next one. This is the Abecedarian program. Again, 1970s, Chapel Hill, North Carolina. Again, a very small RCT. Similar kinds of eligibility criteria, but this time the kids are starting a little bit earlier. Here's the characteristics of the program. This one is full day preschool. So it's 5 days a week, 50 weeks a year, with some up to age 5. So these kids are in preschool 5 days a week, 50 weeks a year, all the way up to age 5. It's very hard to imagine that being able to be replicated in the real world. And they're, again, very intensive on language and cognitive development, but they also do medical and nutrition. One of the things that I think is interesting about this trial is the trial was partly sponsored by Nestle. And guess what they did? They weren't promoting breastfeeding, they were promoting the use of, yes, formula. Anyway, people in public health appreciate that. So that was part of the intervention in the trial that was supposed to help these kids out. Child-teacher ratios, 3 to 1 in infancy, 3 to 1. If you talk to anybody working in preschools anywhere, the idea that you've got 3 children per staff member is, it just doesn't happen. Nobody can afford that kind. And if you compare the two on IQ scores, huge gains in period, but then they fade out by age 20, whereas some of the gains in the Abecedarian ones remain. The Abecedarian program is interesting because they just published a follow-up. They followed these people up to age 32, and they looked at cardiovascular risk factors. So disadvantaged children randomly assigned to this Abecedarian program have significantly lower prevalence of risk factors for cardiovascular and metabolic diseases in their mid-30s. And then they pick out blood pressure, and they say that the mean systolic blood pressure among control males is 143, the mean among the treated males. And remember, this is the treatment that occurs when they're 2 and 3 years old. This is just a follow-up of the trial, is 126. So the effect they observe of this intervention from somewhere around 1 year of age through to about age 4 or 5 is 17 millimeters of systolic blood pressure difference. So anybody that has ever done any work in cardiovascular disease will look at that number and say, that's pretty good. And if you go to one of the meta-analysis of, there's various ones of these, I just picked this one out because it was a meta-analysis of 354 randomized trials. So it's a pretty good one, covering all the major blood pressure drugs. And so, these are the drugs that act directly on the biology of blood pressure. These are direct effects. So what did they find with 354 trials? any of these drugs, it doesn't matter which one you use, they all have about the same effect. Any one drug at standard dose lowered blood pressure by 9 millimeters of mercury. So we're supposed to believe that a program in under fives, that is general language and cognitive development, generates 17 millimeters of blood pressure difference, when the drugs given in adulthood that act directly on the biology can generate 9. So who in the room believes that? No, not so many. This is a really good paper that sort of summarizes all of these interventions in young kids. Here's Perry that I talked about, and here's abecedarian. So here's the effect size that they get, and this is on cognitive achievement. You can see these two are outstanding in terms of the effect size. The other interesting thing you see is that the effects overall, they go down over time. Now, why would that be? If you average them all out, the mean effect size is about 0.3, and then if you weight it by study size, it's about 0.2. The largest observed are up here, Perry and abecedarian. So these effects are going down over time, and that's partly because the control conditions are changing. So when you do a trial in 1972 in Ypsilanti, Michigan, what was available to the control kids? No healthcare, no support, not much of anything. And so your control group, I think, is changing over time, even in America. Certainly in a place like Australia, that the sorts of provision, the universal provision of childcare and preschool and medical care and so forth is changing. So to me, that raises the question of what sort of effects could we possibly expect when control conditions are improving all the time. And it really speaks to whether this kind of evidence is even relevant to us in the 21st century. If you look more broadly, these are interventions that apply quasi-experimental or random assignment. They look at cash transfer, nutrition and education, on cognitive gains, behavioural change. So they look at about 30 different interventions across 23 countries, and you start to see, these similar sorts of effect sizes. They're of the order of 0.2 to 0.3 of a standard deviation. That's about the best we observe. Nothing like the 0.8 and 1 that you see in abecedarian period. So that leads Jack Shonkoff at Harvard. He's writing an editorial in relation to one of these David Oles papers. He says the time has now come for a different approach. We've got to do things differently. We can't keep relying on this evidence from the 60s and the 70s in the US. The marching orders are clear. We must embrace a spirit of constructive dissatisfaction with best practice and design and test new ideas, learn from things that don't work, and look for new breakthroughs. So that's sort of a we're up to. And this is where what we're trying to do fits. We're trying to take that challenge on in some ways. And our type, the term that I've given this thing is interventional epidemiology. And it is trying to use natural experiments. Is everybody familiar with what I mean by natural experiment? No? Sorry, I should have said that before. So a natural experiment is when, services change all the time. The way the health system delivers services changes, or the way nurses do things. So there's a service innovation that happens. So exposure changes. But there's some group who are eligible for the new service, but they can't get it for some reason. So the example I'll show you is we had a change in the way services were provided postnatally. But until they could train enough nurses in the new way of delivering it, there was a waiting list. So people were deemed eligible to receive the treatment, but they were unable to receive the treatment. So do you see how it's like a randomized control trial? It's much closer to a randomized control trial because they're eligible. They should have been treated, but the reason they were not treated had nothing to do with their characteristics. Does that make sense? And this happens all the time. And as we were talking about the potential for data linkage. We do these kinds of natural experiments in data linkage, where there are waiting lists for a new service. So in other words, they're eligible for treatment, but they don't get treated, but their reason for not being treated has got nothing to do with their individual characteristics. Yeah, does that make sense? So that's what we mean by natural experiments. RCTs, you know, and observational cohorts, you know about those. So our goal with our work program is to intervene on the modifiable determinants of these capabilities that kids develop. That's cognitive, social, health, all of the capacities that children gain as they age. Modifiable determinants of capabilities to reduce health and developmental disadvantage. And in some ways, people talk about this as intervening on the pre-distribution of skills. In inequalities research, we're often concerned about redistributing things like income. So you get to be an adult, life hasn't worked out, and we talk about society redistributing the resources. In other words, the rich should pay more to support the poor. This is pre-distribution, before kids ever hit any formal social structure. The only thing they've done is be in their families. So we're trying to pre-distribute the skills required for success in social institutions. And we do three things. The natural experiments that I just talked about, we do pragmatic RCTs, and we use observational data. So that's what I'm going to go through now. This is our example of a natural experiment that we just published recently. And this was the one that I just told you about, where nursing practice changed. They rolled out a new way of doing things, new eligibility, but they couldn't train enough nurses to deliver it to the entire state. So there were parts of the state that didn't get the service, even though the people were eligible. You get it? You just have to be around when this stuff goes on. And it's going on out there all the time. We spend a lot of time trying to get service providers, when they change things, to either roll them out randomly, you know, please, just select areas, select them randomly. These areas get the new service, these don't, and then we've got a randomized trial. If we can't convince them to roll it out randomly, because often that's not politically possible, you can imagine Bolsa Family could have been rolled out randomly, but it couldn't be because it's too politically important. Same is true for Sure Start in the UK. So we try to say, well, at least give us the waiting list. So we're trying to engage health services to improve our capacity to undertake natural experiments that we can evaluate. Okay, and this is the protocol for the trial that we're running. This is the longest title of any paper I think we've ever written. But this is the bit in terms of the design that's important. So it's a pragmatic, preference randomized control trial, but it's also non-inferiority. So does everybody know what those words mean? It's pragmatic because it's not the researchers who do it. The health system does this. The people in the health system randomize the participants. Everything is embedded within the health system. The project, the intervention is delivered by the normal staff. So it's pragmatic in the sense that we want this trial to run within the system, that if it works, we'll deliver it. Often with efficacy trials, it's the researchers that do it all, and the research nurses conduct it, and then you get the result, and then you say to the health system, okay, here, now you do this. And they say, well, hang on, your participants are nothing like the people we see. And that's this gap, this sort of research translation thing. We're trying to run all our RCTs within the health systems that actually have to deliver the services. So that's what pragmatic means. Preference, I should say, this is the intervention. It's a thing called EMALS. Why are we doing EMUMS. EMUMS means E everything, E health, E anything. Why are we doing EMUMS? Because the average age of first birth in Australia is about 30 now, 31. And that generation giving birth use these things. Things that you're all looking at. They do not do pamphlets. You know, all the nice, we put these big things with all this paper and stuff that we sit in the health centre. They don't read those. They don't want a brochure that says, here, this will be important when your child's 18 months old. What? That just goes away. What do they want? They want information off the internet, and they don't want it off a computer. They want it off the phone. Okay? They want it off the phone, and they want it just in time. When that child's throwing up at 18 months, I don't want to have to go and search for the pamphlet that says, here's what to do when the kid's throwing up at 18 months. I just open the phone and I want an answer. It's just in time information. Okay, so that's why we're doing it. Because the way the service delivered information was the old-fashioned way. The average age of a child and family health nurse is 50. That's not how the birthing generations use and access information anymore. So we do EMUMS. And it leverages off the fact that there's a contact with a child and family health nurse, which is highly valued. That clinical professional contact is highly valued, and then the nurses moderate like a Facebook, like a social support group. So the mums, there's 25 of them in each of the groups, and so there's the social support component, but it's moderated by the nurses. So you can have private communications with the nurse. If you've got a question, you just go directly to the nurse, and that's private, but there's also this public social support side of it. So there's a lot of group learning. So somebody says, you know, what do you do with this rash? And people are putting up pictures of the child's rash. And one of these other mums says, oh, look, I tried this and this and this. Fantastic. And the nurses don't have to do anything. If the suggestion is totally off the wall and hurt the child, then the nurse can come in and say, no, I'm not sure that's such a great thing. And then she pulls from the various resources, videos or articles, and then gives it and sort of posts it to the group and says, have a look at this, this might help you. Do you get the idea? So it helps the nurses reach more people rather than having one-to-one clinical contact. But it's also leveraging off the social support sort of Facebook side of things. And it's delivered in a format that is the way young people want to get information. So you can actually click on here and you can see EMUMS working. And we're looking at various advancements to the basic platform. So that's the intervention. Now this slide you can't see, that's okay. I told you it's pragmatic. It is randomized, but it's a preference trial. What I mean by a preference trial is, how many of you have run randomized control trials? Nobody run a randomized control trial? So the first problem with randomized control trials is the people that agree to be in your trial are odd. They are weird. Who would say, yeah, oh yeah, I'd love to be in a randomized control trial? Yeah, they're just not like normal people. So what we do is we elicit preferences. So we can say, would you prefer the new EMUMS program, and we describe it, or would you like standard care, which is the nurse coming to your home and giving you this big bag full of pamphlets? Those who say, they don't mind, they don't have a strong preference, they're the ones we randomise. We can then randomise them to one arm or the other, and that's this group here. So we've got 240 in each arm. But the people who do elicit a preference, we then enroll them and they get the treatment they prefer. So what that tells us is, if we can observe in the randomised arm an effect, but we see the same effect in the preference arm, then that tells us what would happen if we rolled it out population-wide. Does that make sense? Because we know these are the people who would choose it. Does that make sense? That's why we do a preference arm. Anyway, it's a pretty cool little design, I think. All right, so let me keep going. How's the time going? Are you all right? Oh, I don't know what time you started. No, it's about 3:15. Okay. You're doing really well. You're doing really well. This time, Friday afternoon, it's good. Okay, so let me tell you about what we do in the other part of this interventional epidemiology. And this is trying to find new ways to use observational data. And it involves some new techniques that have come along. So we come back to our basic DAG here, where we've got, say, income and some mediator. They're the things that we want to intervene on. So, to intervene on low income, we need to adjust for a bunch of confounding. Adjusting for confounding is nothing more than trying to simulate a randomized controlled trial. So if you get nothing else from this talk, when you deal with observational data, adjusting for confounding is your best attempt to simulate the randomized exposure to low income, not low income. That's what your goal is. So if you read a study that is adjusted for age, sex, and education, that is saying that apart from the differences in age, sex, and education, there are no other differences between high and low income families. That's clearly not correct. There are hundreds of things that differ between high and low income families. So it's very, very important that you're clear in your head that controlling confounding is about making this, that X, a randomized control trial. Now, if you're interested in media, I don't know why we don't teach it that way. That's not how it was taught to me. And it's only taken me about 20 years to figure out that's actually what we're doing. We have this also now. We have this one as well, which is another cause of why. To handle this one properly, we also have to turn this into a randomized control trial because we're interested in X has an effect on Y, and so does M. Okay, so we've got two causes of Y, low income and some mediator. Could be poor quality water, it could be ineffective parenting. Dealing with C, the confounding, makes low income, or it's our best attempt to make low income a randomized control trial. Some of you having trouble with that concept of turning the exposure into a randomized control trial, or is that all okay? I'm not sure whether there was some sort of queried looks on people's faces. Is everyone okay with the idea? All right. So the question is, how do we make M like a randomized control trial? It's one of the other causes of Y. In this DAG, there are two causes. There's low income and the mediator. And that means, how do we deal with L properly? How many of you have heard of these things? Marginal structural models. When you look in, these are the sort of things that, you open up the epidemiology journal and you come to this page and it's full of algebra and formula and your eyes glaze over and you get through half a page and you say, oh, I can't read that. That's one of these papers. But you can actually start to make sense of this. It's taken, I will say, this has taken me over 3 years of concerted effort to understand. So if you don't get it between now and 4:15, don't be too hard on yourself. This stuff is difficult. Just try to get the basic ideas. But it's not beyond us. It's not beyond us at all. So here we've got a data structure. This time, instead of E or X, they use A, and that's very helpful. They change the notation all the time. Just when you think it's all E's or X's, no, now they put A. I don't know why they do that, but not helpful. We've got two exposures, a time 0 and a time 1, and we've got this thing. So we've got A0 and A1 causing Y, okay? So we've got a repeated exposure. But we've got this thing, this L, this thing that's changing after the first exposure. And this L does two things. It mediates the effect of A0 on A1, You see that? That's a mediation pathway. But L also confounds A1 and Y. It's a common cause of both A1 and Y. So L does two things. And if I want to know what the effect of A on Y is, how do I handle L? That could be what's the effect of poverty over time on some child outcome. The original one that motivated this idea was Jamie Robbins was interested in estimating the effect of AZT treatment on AIDS. And when you run a randomized control trial, usually what you do is you treat with AZT and then you follow up for some time period and you count the outcome. So it's a one-off treatment with an effect on an outcome. But that's not how people get treated with AZT in the real world. So we don't have to do AZT, we can do it with blood pressure. So I go to the doctor and I get the blood pressure taken and it reaches some threshold and the blood pressure says, the doctor says, here, have some ACE inhibitor, a calcium channel blocker or something, right? Then what happens? Then I go away for 2 months and then I come back and what happens? My blood pressure gets taken again. And if it's not under control, what does the doctor do? Changes the medication, ups the medication. So if you imagine, I get my first treatment with a drug, and then I come back and I get my blood pressure taken or my CD4 count taken. What causes the next treatment? Right? That second treatment with the drug is caused both by my first treatment, but also by what my reading was here. There's two causes of the second treatment. Does that make sense? So what happens in the real world is not one-off treatments and outcome. It's actually a treatment strategy that's changing over time based on various forms of feedback, CD4 counts or blood pressures. And that's what we're trying to do with child health and development. We want a treatment strategy from antenatally, postnatally. We want a treatment that's changing and adapting over time. Okay, so here's the basic data structure. You've got an exposure at time 0, another exposure at time 2, and an outcome at time 3. And then there's something that varies post-exposure. It could be a blood pressure or a CD4 count. So we're often in this situation with longitudinal data, where my question is, what's the effect of healthy diet at age 2 and 5 on blood pressure at age 10? And I know that diet has an effect on weight, so I measure weight. So weight here is part of the effect of diet. Diet affects weight, but weight also affects the next level of diet. So if I go on a diet and I don't lose enough weight, what do? Change my diet. Yeah, I stop eating the chocolate or I add something else to it. Do you see what I'm getting at? So it's a feedback loop. And there could be other unmeasured causes of this. In this case, the obvious unmeasured cause that affects both weight and blood pressure is physical activity, for instance. But I didn't measure that. So it's a U, it's an unmeasured. So this L is both a mediator of the diet effect, it's part of the effect of diet at the early time point, but it's also a confounder. And it is this dual role that's problematic. So when you've got longitudinal data and you've got this data structure, the question is, what do you do with this? Now, I've done it, I'm sure you've done it. What we usually do is we chuck that thing into a regression, don't we? And we say we get the independent effect of the earlier measure. I can see people nodding. Yeah, you've published papers like this, haven't you? Yeah, so have I. But there's a problem with that. Adjusting for E2 actually removes part of the effect of the early exposure. That wasn't your question in the first place. You've just done a statistical analysis that's not consistent with your question. It can also do this thing where it becomes a collider. Some of you might have heard of collider bias. In other words, there's two arrows going into it. You adjust for this and then you open up all this backdoor pathway of unmeasured confounding. But worse, it doesn't really answer the question of interest. So how do you deal with these L's? So this is a paper that we published just late last year in Child Development. Child Development is the top-ranking child development journal in the world. This is the hardest paper I've ever had to publish in my life because it's run by psychologists. I'm convinced they're from another planet. I'm being very harsh. It shows the disciplinary differences in terms of what we do with trying to deal with complex data and how they deal with it. So this was a real chore. Anyway, we got it in there, so I was pleased that we were able to convince them. So the question is, how much can socioeconomic inequality in educational achievement, that's at age 16, be reduced if we did the sorts of interventions that I talked about before in preschool, antenatal, and postnatal? If we could do those interventions and lower the gap at school readiness when the kids come into school, how much could we reduce the ending social inequality when they leave school? So that was the question. What would that effect be on the overall population levels and the inequality that we observe in educational achievement at age 16? And as I said, we have no answer to those questions. Nobody in the world knows the answer to that because we haven't used the data in ways that allow us to think. Now, I'm not trying to say this is groundbreaking stuff and I'm due for a Nobel Prize. That is not true. It's our attempt to try to use the data a bit better to address these kinds of questions, because these are the sorts of questions that policymakers ask, politicians ask. So we have to use our epidemiological data a bit better, a bit closer to what they're asking. Okay, so the methods. Quantifying this involves two steps. First, we estimate a thing called a control direct effect via a marginal structural model of early life socioeconomic disadvantage in academic skills at entry and achievement. And this, we're using ALSPAC data. Some of you may have heard of ALSPAC in the UK. And then the second part is we use those causal effects that were reported from the randomized and the quasi-experimental trials. I showed you those summaries of all the trials. So we use the effects that they observed in the trials, and we then manipulate the mediator. We manipulate the school entry skills as if we had been able to do a randomized trial, because we know what the effect of the trials is. And then we say, well, the trial has this effect, that means we could shift things in the population this much. That's the simulation part. Using these, the RCTs and the observational data together in one paper, one analysis. So here's our DAG and our research questions. The first one is, what's the control direct effect of poverty in pregnancy? That's path 1 up here on educational achievement. The second question is, what would the population average be and the inequality if we could improve school readiness? That's the mediator. We're going to shift school readiness under targeted and population interventions where we set that mediator to plausible values. The plausible values come from the external randomized control trial evidence. In other words, we augment the observational data with evidence from the randomized trials and then manipulate the observational data as if it had been conducted in a randomized trial. So you get the idea? So yeah, the way we manipulate this thing is that all comes from the external data on the RCTs. Okay, so here's a DAG with our C's and L's and so forth. So these are the baseline confounders. That's our exposure, that's our mediator, that's our outcome. And these are all the L's, the things that change after pregnancy. So these are things like post-pregnancy. So it's the birth weight, gestational age, and a bunch of other things. Okay, and we use marginal structural models, use a thing called an inverse probability of treatment weight. Now, everybody's familiar with that? Of course, aren't you? IPTW, inverse probability of treatment weight. Anybody heard of that? No? Okay. I'm not going to go into the maths of that, and you'll be very pleased that I'm not going to do that. But here's what they look like. The denominator probability of having your own treatment history, given covariates, numerator, etc. I won't go through that. What I will try to do is to say you've been using this since your very first class in epidemiology. You just didn't know you were using it. How many of you did direct age standardization? Epi 101, lecture 2. Yep, you all did it, didn't you? You had your calculators out. What are you doing when you directly age standardize? You've got two populations. This happens to be Aboriginal and non-Aboriginal. And the trouble is, you have different proportions of people at different ages. That's because Aboriginal people die much younger. We have a much younger age distribution. So how does direct age standardization work? We've got one population here with one age distribution, one population here with another age distribution. What do? You choose a standard. Yep. And then you weight this one up to the standard and weight that one up to the standard. Notice the word weight. You're using a weight to upweight the population as if they had the same distribution. Yeah. Then you can fairly compare them. So direct age standardization is population weighting. An inverse probability of treatment weight is exactly the same thing. So you do this stuff all the time. It's just that we're applying it to an issue of confounding in longitudinal data. Can you see that? You've got two populations with different age structures. That means age confounds the two population comparisons. Does that make sense? That's all it is. Now, I was never taught standardization that way, but that's exactly what it is. You're getting rid of the confounding by age by weighting up bits of the population. Does that make sense? That's all standardization is. Okay, so I won't go through that. But what you can do is figure out there's twice as many Aboriginals in one age group as non-Aboriginals, and then what's the weight? It's just 2. The inverse of that weight would be a half. So it's this sort of weighting process. And this is a great little paper that actually just came out in Statistics in Science, I think. And it's a history of how we lost this ability to do standardization in epidemiology because of we now do everything conditionally through regressions. And the reason we do that is because we've got computers that can crunch it all, and we've got proc logistic where we can push the button, chuck all the variables in, and get an answer. Computing power has allowed us to do much more conditional approaches. The old ways were through standardization. So it's interesting that standardization is making a comeback. All right, step 1 of the analysis. Here's the results from the conventional regression, where you chuck this into the regression. Here's the result of the marginal structural model. The point of this is that you overestimate the amount of mediation. So the conventional regression suggests greater mediation by school entry because it's not treating M as a confounder. Now, I know we have to finish, so I might just sort of finish on this point, which is the intuition of why you have to treat L differently to C. So this here, L, what is L in X to Y? Fill in the blank. L is a blank. Very good. And you know that because of which way the arrows go, right? L is actually part of the effect of X. It mediates the effect of X. What's this one? Oh, now, if I run a regression of those things, which we all do, everybody happy that they can read the regression? So here's the coefficient on the X, there's the coefficient on the L, and we say that we now have the independent effect of X on there. That's what the regression does. Now, for those of you who hate reading these things, they're actually quite easy. This is the joint probability distribution of X, L, and Y. By that I mean, imagine plotting the data points on a Y-axis, an X-axis, and an L-axis, 3-dimensional. You see every individual has a value for X, L, and Y, and then another one, X, L, and Y. It's actually a three-dimensional surface. So that's the joint probability distribution. A statistical model is trying to estimate that three-dimensional space. That's what it's trying to do, the joint probability distribution. So what's the joint probability distribution? It's defined by the probability of X. That's because you see in the DAG, nothing causes X, right? Nothing causes X, nothing going into X up here, times the probability of L given X, because in the DAG, L is caused by X, yep, times the probability distribution of Y given X and L, because X and L both cause Y. Comfortable with that? That's all the joint probability distribution is. So this time, what's a L? What do we call L traditionally in epidemiology? We call it a confounder because it's a common cause of X and Y. Okay? Now, if we do the regression of that DAG, the regression doesn't care which way the arrow goes. You get exactly the same answer with those two causal structures from a regression. Accept that? This is why regression gives you the wrong answer for a data structure that you are trying to get mediation. The joint probability distributions are not the same. So this time, this joint probability distribution is defined by the probability of L, because nothing causes L in this DAG, probability of X given L, and then Y given X and L. So these terms are the same, but you see these two are different. So the regression actually gives you the wrong answer. That's why you have to specify what L is, whether it is a confounder or a mediator. And that's what these marginal structural models help you get right. They treat the data structure the way you think the world works. Now listen, I'm going to finish there because there's a whole bunch of stuff that we don't need to go through. Except we also, you can read this one, we just published this one in IJE. And this is about doing something similar with conditional cash transfer programs in Indonesia. So you can do this stuff and actually get it into pretty good journals. You know, the IJE is the top impact factor journal in epidemiology now, actually in public health. But there's a lot of discussion in the literature around using these things. So these are commentaries by very smart people, sort of saying, you know, is this the way forward? And, you know, who knows, watch this space. But it is a way that I think helps us do better justice to the data structures. This is a very, very common data structure longitudinally. We, in the past, have not treated these variables correctly. So I don't think you'll be able to get into the best journals anymore by checking them into a regression, because you'll send it to IJE, they'll come across my desk, and I'll say, no, sorry, you need to go back and have a look at your marginal structural model. But let me finish with this point. This gets much more complicated. Always keep in mind, all models are wrong. They are very, very crude representations of the complex reality we try to work with. If nothing else, be humble with what you can do with epidemiologically collected data, chucked into whatever kind of fancy model it is. They're all wrong, but some of them are useful. That's it. Thanks.
I have like two questions, maybe. I think that these DAG things, they start to be like more popular in epidemiology, like in the mid-90s. So it took like 20 years for this to get more, you know, popular in the sense that you're saying that now it will be difficult to use the old-fashioned models to publish, in the good journals. So why do you think this happened? It took like 20 years for this to.
So I think there's two things. I think first of all, some of this material is very hard to digest. I don't do this because I'm a methodologist. I hate reading these things. They're painful. They're really hard to understand. And it's actually accessible to a very small number of people who have particular technical skills. The only reason I can understand this is because I've worked really closely with a couple of biostatisticians. And I figure if I can get it through my thick head, then it's possible. But the reason I do it is not because I'm interested in the latest methodological thing. It's because I'm interested in longitudinal data. We collect data longitudinally, and we say, well, we have to have longitudinal data because it helps us get at causal relationships. So there was a study in Canada called the National Longitudinal Study of Children and Youth. 13,000 kids at the start, and they had 8 waves of data collected over, I guess, about 14 or 15 years. So almost, once every 2 years. Massive investment. So what proportion of all the publications that were ever published off that data set used more than 1 or 2 waves of the data? Have a guess.
90.
Yeah, it's 98%. 98% of all the publications used either 1 or 2 waves of the data. Why is that? Because it's bloody hard to use more of it. So for me, this helps me think of ways that I can ask more complicated longitudinal questions that are closer to the experience in the real world, where kids are getting exposed to things all the time. And then I come along and I say, oh, well, look, I know there's all this history and I know there's all that, but my model, I can only do this. So I'm only going to use this bit, and I'm going to say to the funder, yeah, we need that longitudinal data. Absolutely, we need it. Please fund it out of the social perks. I'm not going to use it, but it's really good to know we've got it. We've got to do better than that. What did they do with that national longitudinal study? They canned it. And it's partly because it became quite clear to Statistics Canada, who funded it, that this was not being used by the academic community. So, that's a really long-winded answer. I think it's hard. I think we have to find good uses. Now, to me, this is a good use. DAGs really help me longitudinally because these data structures get very complicated. Exposures change, mediators change, outcomes change, confounding changes. This helps me think about what it's more like in the real world rather than be limited by I do a logistic regression in the cross-section, and then I get really adventurous and look at 2 waves and create a change tool, when in fact there are 7 waves of exposure data. So I think it just takes time. We're still a very young discipline. We haven't been around that long. And so I think it's part of the maturing process. But the thing we have to do is to make it more accessible to people like me. I did it because I needed the answers. But I think it's very difficult, and some of these methodologists write in ways that are just way too difficult to understand. You feel like you need Google Translate all the time to get it into proper terminology, and they could do better. Anyway, that's a long-winded answer.
I have a question that, I don't know how many people here are from epidemiology. I'm not an epidemiologist. I'm really found it really fascinating. But I have a question that coming from social science, or how to say, because it's a more general question and a more question on the epistemological assumptions of what you've been doing has to do with the issue of evidence, the issue of RCTs, and also the issue of neuroscience. Because, I mean, the first concerning neuroscience, I mean, you answered the question a bit with what you say about epigenetics. I don't know what you say about epigenetics. You also mean for that it also applies to neuroscience. Because what distracts to me, and I've been doing a lot of work on neuroscience and the use of neuroscience in several fields, like also a bit on psychology and a bit on neurodevelopment, etc. Because, I mean, look, everything that you said about how it's important the first 2 years, the first 5 years, etc., we knew much before we knew about plasticity, epigenetics, and the use of neuroimaging. I mean, as any psychologist, any psychoanalyst, any developmental psychologist, as Piaget 100 years ago would say that, is that, I mean, it's like, you know, like a new discovery. I mean, I'm not a psychologist, but a psychologist, I would say, wait, what you are saying now, we knew for over a century. What are you trying to do? That's something, why we need, I mean, why it's just, you know, neuroscience replies what we already knew from behavioral experiments, from development psychology. This is one part, and that is related to the whole thing of RCTs. I would say that because, I mean, I saw your position as a bit hesitating in giving too much weight to RCTs, because you said you presented these Tennessee, these experiments in Tennessee, in Chapel Hill, etc. So it's different. And you say, well, that is not the real world. That has nothing to do with the kids I know, or the situation I know in Australia, and I don't know, adolescent pregnancy is not a problem in Australia. So, talking about real world, I mean, what do we need all that to get these results? I mean, we already have some results from Bolsa Familia in Brazil. No, many, I mean, how that has improved in school achievement, etc., without nothing of the sort. So, I mean, my question is a very naive question coming from another field, because, I mean, that means a lot of people working, money, a whole structure that, I mean, wouldn't be also important, not only conducting RCTs and even pragmatic RCTs, but also a more interdisciplinary talk to people, economics, people, social scientists, etc. What do you think? Sorry for the question.
Okay. So, part one.
I work with him.
I'm going to have trouble enough answering this one. Another one after. So the first part, I agree with you entirely. We knew all this. But nevertheless, if you look at, so there's a number of ways to reply. I agree with you. But there are sectors of society that are not convinced until there is a biological mechanism. And it is amazing when you look at the effect it has on politicians when they looked at those 2 CT scans of kids. That did more to motivate activity, even though it's a completely inappropriate thing to do. That CT scan of the kid with extreme neglect is actually a child that was raised with a dog. This is a level of neglect that, blessedly, in many parts of the world is rare. But nevertheless, they could see it. So there is this. Let's remember, what did it take for people, well, most people, to believe that cholesterol truly was a cause of heart disease? We knew that many, many, many years. It was not until they ran the randomized control trials and showed that simvastatin did work that all of a sudden it becomes widely dispersed social knowledge. I wish it wasn't the case, because it's obvious. The neuroscience gets misused. the epigenetics, the gene, it all gets misused in some cases. I wish we didn't need it. But I don't know what we do. There's part of the human condition that requires that kind of proof. Perhaps you and I don't, but some people do. And so I acquiesce and I say, okay. So I don't want to can it as an activity that has no value, because I know for some people it's very important. And if we can use it in a positive way without spending too much money, which is unlikely, then that would be good. Now, what was part 2? RCTs. So I believe in RCTs. I think RCTs philosophically, because they create a group which is as exchangeable as we can create it. And if I'm interested in effectiveness RCTs, not in efficacy ones. That's why all the things we do are meant to be rooted in the real world. Because the lack of transferability, you see some of these programs, and my point was, there's no system in the world that would support this. So why don't we try things that we can actually support in existing health systems with existing workforce and see what we get? And maybe it won't be enough, but we can stop sort of making naive political promises about the effects we can have with programs like Bolsa Familia. You know, it's going to change the world. Well, it won't. So part of our strategy with doing this in Indonesia was the Indonesian government had a similar program. And we were trying to show that the cash transfer they were offering was way too small for the effect that they claimed. And indeed it was. It was a trivial effect. So we were trying to show, look, you're doing this, but it won't solve everything. And it comes from, sorry, I'm starting to get into cash transfers now. It's politically, the right wing quite like it. You know, we give you money and then you can make choices within the free market. But actually it doesn't flow through to better health and development for the kids. So I like RCTs. In some cases, everybody knows what the answer is. Sometimes we don't though, and RCTs are helpful. Let me say one more thing. We do spend money, governments spend money on very expensive programs that don't work. And that's unethical. And if we're not willing to find out if they work or not, that's not right. So there are many examples in Australia of, there's plenty of academics around the world who corporatise their research and sell programs to people. There are plenty of examples of that. We have examples in Australia where people have been paid over $40 million for an off-the-shelf program that doesn't work. But they have the political connections, they have all this stuff, and I'd rather have an RCT to show that's not a good investment.
Okay, I thought the imams program, that was very interesting, and I'm curious to understand, because if a nurse has to manage a e-group, that has, I would like to understand if that is included in her working hours, or if she does that in her leisure time. I mean, does that become part of her role, of her professional role? Do you understand what I'm trying to get? And the other question is, I'm also from the social science, so I didn't follow part of the presentation, and I'm curious to know if you have people from social science in your group, and how do they help you? How, what is their contribution if you work with, people from the social science?
So the answer to the first question is yes, that's their job. It's part of their job. That's why we do the trials within the health system. Because if this works, the nurses will have to deliver this as part of their normal paid routine. And so it has implications for their training, for their scope of practice and what normal work is. At the moment, the nurses visit homes So they go to a home to conduct these visits. And these are highly skilled clinicians, these women. Great experience, but it's an incredibly expensive way to deliver a service. So they will go and visit a home where one of the partners is a pediatrician, the other one is a university professor. It's the third child, and we sit and have a cup of tea and a chat. It's lovely. This is not an effective way to spend public money. So what we're trying to do is to find, it doesn't mean we take that away. We're just trying to find somewhat more cost-effective ways for the nurses to share their expertise with more women, with actually more contact availability, but also with the social support of other women who are mothers of similar age children. So the nurses do this as part of their normal, highly unionized work practices, and it's built into their normal workflows. Yeah, which to me is the point. That's why it's pragmatic. It has to be part of what the nurses are willing to do. And the nurses like it. So we work very closely. This is not something we give to the nurses to say, here's how you're going to do this. We've worked with them for 2 years to figure out how this could work. They teach us much more than we teach them. They change the curriculum. They change the way things work. It's a very collaborative enterprise because in the end, it's their jobs. And it has to work in terms of their normal work practice. So that's the first part. The second part is, yes, I work a lot with social scientists. Psychologists and child developmental people, mainly. And we collaborate very effectively. Working interdisciplinary, in an interdisciplinary way, it requires a lot of time together talking to share frameworks and how you see the world. You see it differently. And it's those opportunities for interchange, I think, that we don't give enough time to. But I work with those social scientists, also with demographers, and increasingly with economists. And economists are the hardest ones to work with because they're all very arrogant. They know everything. They know everything about everything. And the great thing is, economists never have to collect data. All economists do is they come over and they take your data and go and play with it. They don't know what it's like to go into somebody's home and sit down with them and how you collect this information. Yeah, so they're the biggest challenge at the moment. Thank you. I think we could. Thank you very much. Delighted.